So like Tim said, I'm Stephanie, this is Rachel. We're your resident experts in AlignRT for clinical applications. And the most common question we get in the field from customers is, why is it doing that? So our objectives for today, we're first going to discuss reasons for poor quality images and how they can affect the workflows in your clinic. We'll then discuss delta fluctuations during ARC treatments and how to resolve. We'll also discuss the insufficient surface overlap message, what it means and how to avoid it. Bolus workflows and commonly seen issues related to bolus, and issues related to the beam hold interface and how to avoid them. So what is poor quality surface image? This is characterized by black holes or missing data on either a VisionRT reference or treatment surface. Insufficient data can be unavailable here.
An example is the reference image right here. We're missing all the information at the center of the patient, which is where our ROI is. We can see on this next image that we have our treatment capture surface is missing information as well. This is a real patient, not just a phantom, and we can see that we're missing a lot of information on that lateral side, which is also the area of the ROI.
Insufficient topography in the area of the ROI can also cause poor quality surface image.
So an example is a very flat-chested patient. In this case, this patient has almost no topography, no change in their surface anatomy in the area of the ROI, so that's probably not going to be very sufficient. We're probably going to see some misinformation, especially in the longitudinal direction.
So challenges related to poor quality surface image. It's possible to have improper setup. Some difficulties during monitoring could include false patient movement, added time to check if our patient has actually moved, delta fluctuations, and our insufficient surface overlap, which would result in no delta information. So, what causes a poor quality surface image? If we take a capture with the wrong skin tone, if we capture or are monitoring with a camera blockage, if we have improper or inadequate region of interest, if we include any immobilization or treatment devices in our region of interest, or if we have lighting in the room that casts shadows. Patient anatomy can also block our cameras and ointments that cause the skin to be too shiny. And last but not least, camera malfunction. So, what are speckle images? These are pictures captured by the camera whenever a VisionRT surface is captured. It allows us as VisionRT support staff to evaluate why you're having poor quality surface images. So when we log in, what we can see is what the camera is seeing when you took that capture. Was there a camera blockage? Is your room lighting off? Is there shadowing on the area of the patient? Is the patient anatomy incorrect? Or what's causing this poor speckle quality?
So this picture is a representation of actually a good speckle image where we can see that speckle pattern on the patient. It's defined. We don't have any washout, any areas that are too dark. We can see the defined edges of the speckle pattern, which I think looks like static on TV. And this is just a representation of what the lateral camera sees. So these images, they're usually they are in the background. Customers usually don't see them. But we use them a lot when we're trying to diagnose an issue, especially if a customer is complaining about poor monitoring or poor surface capture. That's one of the first things that we'll look at is what does the camera see when it's taking its image. That can really help us diagnose.
So AlignRT has 3 different skin tone settings, fair, mid, and dark. Each of these skin tone settings has an exposure time associated with it. So fair has the least amount of exposure and dark has the most. Like any photographic camera, the time of exposure determines how much light we use to capture that image. Too much time would overexpose our image and too little time would underexpose the image. Anytime we've used improper settings, we can have insufficient surface data or black holes present on our surface image.
This picture is our Emily Phantom. And if anybody's seen her, her surface is white, but we've used the dark skin tone setting to capture this reference. And we can see that dark skin tone setting overexposed, so we have missing information in the area of the ROI. This is an actual patient. We can see again, not as big of a change as what we saw with the Emily Phantom, but we have some missing information here. If that were to leak into the area of the ROI, that can cause us some problems with monitoring and definitely problems with setup. The speckle image on these patients with the wrong skin tone setting might not look so great, so we can see that the speckle pattern is a bit more washed out than what we saw on the other images. And although the lateral actually doesn't look so bad, we can see that anterior surface of the patient is definitely being washed out.
So AlignRT is not able to monitor anything in these black hole areas, and if you were trying to acquire SSDs and you had a black hole where that SSD was coming from, you would also be not able to get that there either.
So the solution obviously is to ensure that you do have the proper skin tone selected. This might mean that you have to recapture with a new skin tone setting. So if you capture, you notice a lot of missing data, try and change the skin tone and see if you can get a better capture.
So what happens if we block a camera pod? AlignRT typically works in that 2 to 3 camera setting, so those 2 lateral cameras and 1 central camera. If we block a pod while capturing a VRT surface, this is going to reduce the amount of surface we have available.
Sorry. Our reference surface here is a good representation of what happens when the camera is blocking the pod, especially the pod that's looking at the ROI. So we can see that all that missing information is not going to be useful to us. We can't monitor anything in that area, and that area is actually in the ISO center. So we might be able to get away with a little bit of monitoring, but we certainly wouldn't want to use this tomorrow for setup. So these are things that we want to be mindful of when we're capturing the image. When we look at the speckle pattern, we'd actually see the gantry or the imaging arm or whatever is blocking the camera in that speckle image. And our solution is obviously to ensure that the gantry, the imaging equipment, or whatever is blocking the camera is not blocking when we take that reference capture. So this may mean moving the gantry to get a good image capture.
Blocking a pod while monitoring could also reduce the ROI visibility.
So here we can see, just like the other picture, we are blocking the pod on the side where the ROI is, which means that we have a lot less area to work with when we're doing our monitoring. Our solution is to ensure that the ROI is sufficient to account for the camera blockage. This is especially important during ARC treatments.
Regions of interest. So region of interest selection is one of the most important parts to successful SGRT. A patient's anatomy must be considered.
So for instance, again, our flat-chested patient, we don't have a whole lot of topography. So again, this ROI is probably not going to give us very good information, especially during our setup. We also might notice some issues during monitoring, and if we're doing any kind of ARC treatment, this ROI would not be sufficient. So our solution would be to ensure that we have appropriate topography included in that ROI. So a good ROI, especially for an ARC, but in any case, a good ROI would have more topography. For instance, we could be including the rib cage without including the abdomen. If we include the abdomen, we'd probably see too much breathing motion. So we want to include the edge of the rib cage, but delete out any of the abdomen. We could also include the head of the clavicles. This is good bony anatomy for us, something to anchor the system to. And lastly, we can include both. We could include the head of the clavicles and the rib cage. And again, it's always important, especially for those ARC treatments, to make sure that we're wrapping the ROI across the body and getting both lateral sides of the patient.
ARC therapy is going to present additional obstacles due to camera blockage.
So again, our solution is to ensure appropriate ROI is drawn to account for the camera blockage. And it might be possible that you create a setup ROI and a monitoring ROI. So in this case, we have our setup ROI that's just the area of maybe what we're treating. Maybe this is a left chest patient, left-sided lung patient. So we might just decide to use that ROI for our setup. But for monitoring purposes, we want to make sure that we include the ROI on the opposite side so that when the gantry is moving, it doesn't block the camera and prevent us from treating. And then obviously the information on the lateral side of what we're treating. So the ROI that works with stationary gantry angles may not work with that ARC treatment. Again, this ROI, although probably wouldn't be good even for stationary, you could get away with something like this if the patient had more topography, but you certainly want to extend that across the chest and get those laterals with the gantry rotations.
Immobilization devices should not be included in our region of interest. So one great feature of our region of interest is that it's going to alert you if the patient moves. And if we included any immobilization devices in that, it could counteract that feature. So treatment devices can also reduce the quality of a surface, but are necessary for treatment. So if we include regions of interest where they are near treatment devices, we can cause problems with registration as well.
So our solution is to ensure the immobilizations are not included and ensure treatment devices are not included, and also to give yourself a little bit of margin between the edge of that, for instance, a compression band, between the edge of the compression band and where your ROI is, so that you can account for any of skin that's manipulated, especially with those compression bands. We just don't want to abut the ROI to that band. So our example here, if we had the area highlighted for our ROI without the compression band, if we put our compression band on and took a reference image, we can see that most of our ROI is actually gone. This is not very good for monitoring, and certainly not good for setup. So what we might want to do is draw an ROI that's maybe a little bit more superior so that we can avoid the compression belt and allow a little bit of distance between the edge of that device and the start of our ROI.
So room lighting, ideally,
That's a fire drill.
ideally, monthly calibration and daily QA should be done at the same room level lighting as treatment. We'll evacuate when they tell us
Should we
to.
leave?
Attention, an emergency has been reported in this building. Please cease operations and leave the building. Utilize the nearest exit.
That's it,
Okay.
folks. And we're out of here. Ideally, your monthly calibration and daily QA should be done at the same room level lighting as treatment. Changes in room lighting or objects in the room could cast shadows on the patient or result in poor surface capture.
So this example is if you look at this side of the patient where the laser pointer is, I think it is her left side, you can see that it's much darker there. So we're not really getting a very good speckle pattern, which means that we're not going to get a very good surface capture. So it's important to be aware of those things too. If you have, for instance, a light bulb goes out, it's really great to do a new monthly calibration at that point so that you can kind of reset that data and make sure that it is set up for what your room lighting is.
Immobilizations, devices, and gowns can also cast a shadow depending on the position that these are placed in.
So for instance here, we have something like maybe a gown that was pushed down on the patient, casts a little shadow where that arrow is, and that information is not available to the system when it takes that surface capture. This is another example, although probably not detrimental, just an example of how the bolus laying on the patient's skin can cast a shadow, and those shadows can affect the speckle pattern. So something to be aware of if you have something in the room or something on the patient, treatment device, something that casts a shadow, it could affect how your image capture is going to look. So our solution would be to ensure that your same room level lighting is used for monthly calibration, daily QA, and your patient treatments. Ensure that no objects are casting a shadow on the patient's skin.
Depending on the anatomy of your patient, this can also cause poor surface quality due to camera blockage or shadows. If we have a rotund belly, we could block a portion of that central camera.
So same picture again, if we had a large abdomen on this patient, depending on where the couch is, the height of the couch and whatnot, it can also cast a shadow, so we could see some missing information in that area.
Large breasts can also cast shadows on the inferior surface of our patient. Ointments or bandages can also affect our surface quality if they are very, very shiny or if they're a different color than the patient's skin tone.
So our solution would be that if a patient's anatomy is the issue, there might not be anything you can do with that particular patient, but it's something you can take forward with you and perhaps change the setup in the sim of a patient who has similar anatomy. If you have shiny ointments, make sure the patient's wiping them off before treatment. And if your bandage can't be removed from the patient, just tell them that next time they get a dressing change, they could maybe select a different bandage, or you can remove that from the ROI to see if you get better results.
If, God forbid, your camera malfunctions. So if it doesn't function properly, we might have a poor quality speckle image. Oftentimes, this could be a one-off instance, so you can try recapturing. If that doesn't work, you can power cycle your cameras, turn them back on and capture again. If that doesn't work, give us a ring and we will come fix it, which might require an on-site visit.
So this is an example of something that just happened to me on site, I believe it was last week. We had been using the system, everything was working great, our reference captures looked great, and we got a reference capture that looked like this, where this information was missing on the lateral side of the patient. We checked to make sure nothing was blocking the camera. We tried another image, didn't work, tried a third image, didn't work. Thankfully, we had enough information to continue treatment on this patient. But what we discovered when we got the patient out of the room was that the projector wasn't turning on that side of the patient. So what was happening on that speckle image is that there was no speckle pattern in that area. So that's why we were getting a reference that had this, so that looked like the camera was being blocked because the camera wasn't participating at all. So we recycled power of the cameras, and thankfully that resolved the issue.
Delta fluctuations are characterized by our deltas either being jumpy or by the deltas moving, not due to patient movement but remaining stable.
So I'm going to just show a quick video of what we consider to be jumpy deltas. And the reason that we show this is that we want to make a difference between jumpy deltas and the deltas moving but becoming stable. So we see the deltas jumping on that video. This is a little bit different than what we see in this case, where we have our phantom head. When we're at couch 0, everything is really close to 0 within 1/10 of a millimeter. We rotate the couch to 90, the phantom hasn't moved at all, and we can see some changes in pretty much every direction. So just something to think about when you are reporting, if you're reporting any issues, jumpy deltas versus the deltas moving but becoming stable.
This is generally seen during ARC treatments or when we have those large table rotations.
So challenges to this are obviously it's difficult to monitor. False patient movement can add extra time because you're not sure if the patient moves, so you want to check to make sure. So it becomes a challenge for everyone when this is happening. We see this more often, I believe, with SRS cases. So one of the things that was discussed, I believe, well, in a couple of the talks, was the region of interest on SRS cases, making that mask, making it big enough. We like to say 2 cm above the brow line and the tragus of the ear is great for opening and for drawing that ROI. Also, something to think about with those SRS ROIs is that we want to avoid including the mask in the ROI. So a lot of times what we see is that those changes in the delta fluctuation can be from just a small ROI or not enough good topography on the ROI.
So, poor quality surface image could cause our delta fluctuations, along with insufficient or improper ROI selection, as Rachel just mentioned, camera blockage, couch walkout.
So couch walkout is interesting to me because I never knew about it until I started working for AlignRT, and we're going to talk about it on the next slide, but I just wanted to show a picture. This actually is from a paper that was done, I believe it was about QA procedures, and they were defining the couch walkout on this particular clinical machine. So the representation is just that at different couch angles, the couch was walking out, I believe, in the vert and lateral directions, so they were having some little movements that weren't necessarily registering when they rotated the couch. And this is just my little citation since it's not my image.
While we aren't experts on couch walkout, we do know that it is important when you're using SGRT. So what is couch walkout? When you rotate the couch, it is possible that the couch will walk slightly, moving the long lat and vert, yet not registering this movement on the couch readout. This can cause AlignRT to show delta movement even though the patient has not moved and it does not appear that the table has moved per the couch readout. It's often evaluated by physics via a Winston-Lutz test. This Winston-Lutz result often reports this as an average of couch walkout. But when you're using SGRT, it is important to know the couch walkout at each couch angle to help determine if the patient has moved or if the SGRT tool is reporting couch walkout. So couch walkout coupled with other issues, such as an inadequate ROI, especially on our SRS cases, can magnify these issues.
So the solution, unfortunately, is it's your site's discretion as to how to handle this, but the best advice we can give you is to know the exact couch walkout at each angle. Now, of course, there's going to be things brought up like, does it matter how heavy the patient is, things like that. I can't respond to that, but we do know, we have seen that couch walkout is an issue, especially for those SRS cases because we are rotating the couch. So the more information we know ahead of time, not just an average of all couch walkout, but specific couch walkout on the angles, can definitely help us determine what we're going to do when we see it on our patients.
So if we see insufficient surface overlap on our screen, this means that our system cannot see at least 25% of our region of interest, and it's going to stop displaying our delta values and inform you that there is not enough information or ROI to process.
So this is a picture of what you would actually see if you were getting insufficient surface overlap. So we see that we actually have no delta information. We have no readout here, and then we have a red banner at the bottom of the screen indicating our insufficient surface overlap. This presents a challenge on number one because a lot of existing users who had older versions of the software never had this, so they never had to experience where all of a sudden they had no delta information. When you're interfaced with beam hold, we will hold beam when that happens, and if you're doing an arc treatment, this can really cause a problem because if you can't get that information, you're not going to be able to continue your arc. So just a quick video, every time you see the red banner at the bottom of the screen, we would actually be holding beam if you have a beam hold treatment. So obviously that's very frustrating.
So some causes of insufficient surface overlap, again, camera blockage, inadequate regions of interest, poor surface quality.
And obviously our solutions, just like we've been talking about, ensure you have proper surface capture techniques, you have a good ROI, especially for your VMAT plans and your table rotations, and that you've taken all measures to prevent poor quality surface.
Bolus. So if you're using bolus for treatment that was not used during stimulation, this could also present challenges with SGRT techniques.
So the big challenges that we see are that it changes our workflow. The shiny bolus can cause problems with our surface quality, and then DIBH with bolus workflow is a little bit tedious.
So when a DICOM is used for daily setup, adding bolus will cause that DICOM to be out of tolerance even though our patient was properly set up.
So this is a picture of a patient with bolus, or a mannequin with bolus. So prior to putting the bolus on, the patient was in tolerance. When we put the bolus on, as you can see on the green surface, you can see the bolus there, it caused the patient to become out of tolerance. Now obviously we don't want to monitor the patient out of tolerance just to see if they go further out of tolerance. So we want to capture a new reference.
A Vision RT surface must be captured to properly monitor any patient who has bolus that is not part of simulation. The site may choose to create an additional field to capture this VRT surface.
So this would represent what your tree would look like in record mode. You would import all of your normal information and then just add a bolus field to your plan. And then you can use that in treatment mode to capture your bolus reference. You want to create it ahead of time though, because you can't create it in treatment mode. If you don't have it, you're kind of stuck.
Since a Vision RT surface with bolus will be captured each day, bolus is used every time the user opens the patient into treatment mode. That Vision RT bolus surface will be the first thing that automatically opens.
So the solution, when you have this changing of the workflow, establish a protocol for each bolus patient so that you know ahead of time what you're going to do. If you plan to use the bolus field, create it in record mode prior to that first treatment, and ensure that you have a proper surface, that you're using your proper VRT surface for your daily setup.
If we have a shiny surface, this can also result in a poor surface image, especially we'll see this in DIBH with bolus. We can have poor monitoring results.
So this is something that we can see, or that we see when we have shiny bolus, is that the ROI is really diminished, and so we don't have necessarily good monitoring, and we certainly don't have any kind of good information for setup. Our solution obviously is to ensure that your shiny surface is covered. So what we've seen works really well is damp white or brown paper towel or bolus material with that white backing. So this is a reference image where the bolus actually looked really well. We didn't have that shiny surface. We have a nice ROI that we can use for monitoring just for today. And our speckle image, we can also see that it looks really good. Our speckle pattern is very well defined.
DIBH with bolus requires a new VRT capture during breath hold. This is difficult because it requires steps to be performed in a specific sequence for the best results, and there is a small period of time where the patient is not monitored.
So our solution is to establish a procedure ahead of time, and I like to use 2 therapists in the room. I think it works better. And actually, just to give you an example of a workflow that you could use for DIBH with bolus, you have 2 therapists in the room. We'll call therapist A will be with the patient, therapist B will be at the AlignRT workstation, and we're going to be monitoring on that DIBH surface. Therapist A will ensure that the gantry is in the treatment position and all parameters are set, the field lights on and the MLC are retracted. More or less, we want everything set up the way it is going to be so that we can see the field and we can ensure that our bolus is properly placed. When everything is in treatment position, therapist A will request the patient to take a breath hold. Therapist B will monitor AlignRT and let therapist A know when the patient is in that breath hold. When the patient's in their breath hold, therapist A will place the bolus while therapist B will stops monitoring, selects the bolus field if you're using one, and selects capture reference, but then waits, doesn't actually select yes to the question of do you want to capture. Therapist A will alert therapist B when the bolus is placed, and therapist B will select yes on the message, and the reference capture will be taken. Therapist B will then tell the patient to breathe, and therapist B will ensure that there is an adequate ROI on the new reference surface. And we're going to continue monitoring then for our treatment with that new VRT surface, but only for today. What's really important, not on this list, but very important, is to actually talk to the patient before you do this procedure so that they know they're supposed to hold their breath the whole time, even if the red light goes out, even if they hear the therapist saying okay to each other. So something that I like to always say to the patient is just hold your breath until I tell you to relax. And then it's also important to tell them that if they, for some reason, need to breathe before we get that final capture, to just let the therapist know that they weren't holding their breath. We can just go right back to that setup and start over. So it's not a big deal if it happens. It's just really helpful if they tell us that it does happen in case we don't see it. So we do have a little video, but I'm going to skip it because of our time. But it's just a video that shows you exactly what we just talked about.
So the beam hold interface is what allows us to automatically hold the beam if a patient moves out of tolerance on AlignRT. On Varian, we call this MMI or EXGI, and it usually accompanies our ADI. Due to the communication between the LINAC and AlignRT at all times, we must follow proper steps to ensure the connection is established and treatment is not unnecessarily interrupted.
So our challenges would be a loss of communication between the LINAC and AlignRT, and then some various interlocks on the Varian LINACs.
Our loss of communication typically results from our steps being done out of order. It is important to ensure our treatment application on the LINAC is open before we open up AlignRT. If at any time we close that treatment application, we should also close AlignRT and then not reopen it until we've reopened the treatment application. We want to make sure we see that LINAC icon in green, not in blue, and that dot yellow or green to make sure we have that connection established. If you're a customer that has a key switch or other device to allow gating, you want to make sure those devices are properly set first, so the key switch to on before opening the AlignRT software. On the Varian LINACs, on a TrueBeam, we can see 2 interlocks, authorization pending or a plan mismatch. And on the C-Series, we see ADI auth and CDOS. So authorization pending.
This is just an image of the TrueBeam screen, so we would see the authorization pending in that top, well, when we're facing it, it would be the top right corner of the screen.
This is an interlock because AlignRT has not yet authorized the field. AlignRT will only authorize on a treatment field when
TrueBeam is in prepare mode. The parameters on the LINAC are near or in tolerance, and this is also applies for the couch. And the patient has been in tolerance for at least one frame on AlignRT.
AlignRT will only authorize on imaging fields when
TrueBeam is in prepare mode. Parameters on the LINAC are near or in tolerance, including the imaging arms. An authorization checkmark on AlignRT has been selected. And just for a note, the patient does not need to be in tolerance when we're doing an imaging field.
a plan mismatch.
So just a representation, if you have a plan mismatch, it's accounted for in the clock icon. It's I believe it's the busy icon is what Varian refers to it as.
So this interlock is caused because the device selected on the TrueBeam does not match what we've selected within AlignRT. So hovering over that clock icon will inform the user the reason for the interlock, and if it was a plan mismatch from AlignRT, it will indicate that it's coming from there. To clear this interlock, the following conditions must apply.
So we must either have none selected in the motion management device window on TrueBeam, and then AlignRT would have to be an auto-authorized, or AlignRT can be used, but the gate beam cannot be turned on. Or AlignRT is selected in the motion management device window, and on AlignRT, the gate beam is set to on. So the motion management device window on TrueBeam, we have the selection of AlignRT and none. The only time we want to select AlignRT is when we're going to use it for beam hold. So when we select AlignRT on TrueBeam, gate beam has to be on, otherwise we'll never let you beam on.
So our ADI off.
Just a picture of this. So you would see the yellow interlock at the bottom of the 4D ITC screen. If you click on it, it'll just tell you that AlignRT has not authorized.
This is an interlock, like she said, because AlignRT has not authorized the field, and AlignRT will only authorize the treatment field on C-Series when?
Just like TrueBeam, C-Series has to be moded up. Now, when we say mode up on C-Series, we kind of have mode up referred to twice, mode up on the 4D ITC screen, and then mode up on the key console. So in our cases, we're talking about the key console. You can mode up your patient, go in the room, set them up so you can see all your parameters. It's not until you mode up the actual key console where this is going to happen. So we mode up our key console, our parameters on the LINAC are near or in tolerance, and the patient has been in tolerance for at least one frame on AlignRT.
AlignRT will then only authorize on an MV imaging field when
C-Series has been mounted up on the key console. The parameters on the Linac are near in tolerance, including the imaging arms, and the authorization checkmark has been selected. Again, patient doesn't need to be in tolerance. One more thing to note about C-Series is that we won't interlock the KV or the CBCT. So even though you will see the ADI auth interlock, we won't actually interlock the beam. We'll only interlock on the MV until you select the authorized button.
if you see a CDOS interlock. This is a general interlock. In relation to AlignRT, it's typically seen if the beam is interlocked due to a bad workflow. So did we pause monitoring during delivery when we had gate beam set to on? If the beam is being held and then we time out. Or if our frame rate is too low. So let's say we've captured a bolus surface and we didn't draw a region of interest. Or when we took a new surface, our ROI did not propagate. And the system is then using the entire surface for the region of interest.
So just to show what that would look like, if you take a reference capture and you see a solid pink surface like this, it means that the system is trying to use the entire surface as the ROI. When it starts to monitor, the frame rate is going to be incredibly low. And what we've noticed on C-Series is that it causes the CDOS interlock, and you're not going to be able to treat. So if you ever see that solid pink surface after you take a reference capture, just edit your ROI and draw it back in.
If you need to recycle camera power. So if you ever have an issue and the cameras are not working, it's often resolved by a simple power recycle. If you have a wall switch present, you're just going to close the software, turn the cameras off, turn them back on, and reopen the software. If you do not have a wall switch, you will be climbing into the ceiling to manually unplug the cameras above the central camera.
That's all we got. You guys got any questions?